if not lower the global standards, implying a pent-up demand for increased mobility. From the other hand, the renewable energy share is also below 6%, although we do have potential for increasing, but also potential for in tapping these resources in the region. And very few policies when it comes to mobility, but also renewable energy exist in terms of looking how to improve the mobility, how to improve the transport, but also how to improve in terms of vehicle ownership and system energy efficiency, while also high levels of pollutant that still exist in the region. The share of renewable energy when it comes to the Arab region is really becoming more significant when it comes to the energy mix, and specifically when we see the share of renewable energy when it comes to electric vehicles. So it's really opened up a new sector for the uptake of renewable energy. And it's certainly an economic pathway that will provide more efficient transport facilities, but also sustainable travel for all. But from the other hand, if we take the electric vehicle, and this is the challenge because it's becoming really a challenge when we take the whole value chain. Just an example, if we take an example of electric vehicle, for example, it's just a standard that requires 6 times more the quantity of certain minerals compared to a conventional vehicle. And there, the need to examine the shortages in terms of the supply. When it comes to the demand side, we need really to look at the supply side from critical raw materials for the energy transition, specifically for deployment of electric mobility. For the ESCWA region, the Regional Commission of Western Asia that takes care of the Arab region, and given that we do have in our region really high efficiency of power plants, be it run by natural gas or renewables, and we do have also the quantity of certain minerals that can help to drive this transition. We do have also good prospect for renewable energy that can help also to the uptake of electric vehicle, which make it also an economic and sustainable pathway for sustainable transport. But as globally, the most world regions that we look at, we need really a multidisciplinary and integrated approach in order really to adapt our strategies in a way that for the uptake of electric vehicle, but also in terms of the sustainability and achieving SDG 7 related to energy. Today, hybrid events that's looking, as my colleague Jill indicated, looking to the electric vehicle in terms of market enablers. We intend to really, our intention is to build the capacity of our member states to inform also on the experiences and the business model that we have in China, based, for example, looking to the infrastructure needed, the system, the technology needed for electric vehicle, but also related policies and enablers and regulation, how make the business model fully sustainable and obviously look into more integrated solutions. This capacity building actually built on a very fruitful and successful collaboration that we have with our strategic partner, the Global Energy Interconnection Development and Cooperation Organization, JEDCO. And this is really in a way that to reverse knowledge and learn from the Chinese business model. We also value the electric vehicle program in our member states, the Hashimiya Jordan, where we really intend to look in how the prospect of this market and what represents so far as a blind spot in the region as an evolving market, thanks to an enabling environment that the Ministry of Energy and Mineral Resources put in place. Then, without further ado, let's listen to the experts and learn more from the key enablers for the sustainable transport in the Arab countries. And I would like to wish you success in this training. And I would like also to hand over to my colleague, Jill, but also to from JEDCO, Dr. Jane. Thank you very much.
Thank you, Radia, for the warm welcome. And before I give the floor to Dr. Cheng, who's going to give his word in Chinese, I have to ask all the participants to click on the interpretation icon and switch to the English channel so they can listen to the interpretation in English for Dr. Cheng's word. So please, everyone, switch to the English channel under the interpretation button in Zoom. I give the floor now to Dr. Cheng for his welcoming remarks. Please, Dr. Cheng, the floor is yours.
好，尊敬的瑞迪亚司长，各位学员，女士们、先生们，大家好。 首先，我代表全球能源互联网发展合作组织，对于中国电动汽车市场发展的经验、能力建设培训班的开幕表示热烈的祝贺。本次论坛呢，是合作组织和联合国西亚经社委共同举办的一次专业培训的一部分，是我们今年在全面向西亚北非地区呢举办活动的一个重要组成部分。我们将一起开展区域能源相关的主题研讨，进一步的加强清洁能源的知识在阿拉伯地区的传播和应用。本次培训班呢，是面向西亚各个国家，即在分享中国电动汽车发展中的成功经验和启示，为阿拉伯地区的电动汽车的发展和能源转型提供经验和借鉴。全球能源互联网呢，是生产清洁化、消费电气化、配置广域化的能源系统，是清洁能源在全球范围内的大规模开发、输送和使用的一个重要平台，具有清洁主导、电为中心、互联互通、多能协同、安全高效、智慧灵活等主要特征。多年来，合作组织与联合国西亚经社委以及相关国家政府企业机构在举办高级别会议、对接重要的国际机制、专业研究、学术期刊、联合培训等方面开展了密切的合作，取得了丰硕的成果。2024年呢，合作组织希望继续包括联合国西亚经社委在内的各个区域合作伙伴，进一步的在培训活动、联合研究、示范项目建设等方面开展务实有效的合作，努力为各地区能源的转型和人类的可持续发展做出更大的贡献。最后呢，预祝本次培训活动取得圆满的成功，也特别向联合国西亚经社委达什奇执秘和在座的各位领导表示崇高的敬意。谢谢大家。
Thank you, Dr. Cheng, for your welcoming remarks as well. And allow me now, please, to move on to the first session of today, titled Chinese EV Market Overview and Technical Enablers. This session will be given by Mr. Feng Ni. He's a senior expert at Nadi Group, and he's also the chief expert of EV infrastructure at the State Grid Corporation of China. He's also the Deputy Secretary General of the EV Charging Facility Standardization Technical Committee at the China Electricity Council. Mr. Ni, the floor is yours. If you can please start by sharing your screen and opening your microphone. Thank you.
Okay, thank you very much, Joe. Can you see my screen now?
Yes, we can see it.
Okay, perfect. Let me start the presentation. Okay, so good afternoon, good morning, everybody, and I'm Ni Feng from Nadi Group, State Grid, and I'm very happy to have this opportunity to share some information regarding the EV market here in China, especially from the technical point of view. You know, I'm personally in charge of the standardizations here in China, and also participated in the almost half of the process of development of the charging infrastructure here. So my presentation will mainly cover, give you some information about what we were done and what we are doing and what we're going to do in terms of the EV and specifically the charging infrastructure. So, so my presentation consists of several parts. The first one, I will give some overview and I will introduce some typical energy supply technologies we currently use here in China, and also some other developing technologies here. And also I will use this chance to give some introduction about the newly invented the DC charging interface, the next generation DC charging technology called ChargeG. And last but not least, I will give some introduction about the standardizations here. So first of all, from this slide, you can see some outstanding numbers here. So you see for now, until last year, China already has the over 20 millions of the new energy vehicles running on the road. And the penetration rate is almost over 6%. And among all of these new EV, we have over 76% of the vehicles are pure electric vehicle. So this was also a very first strategy that China used 1 decade ago. I think at that time, China already decided that we are going to use the pure electric vehicle. We will skip the combustion engine and hybrid vehicle. Even the plug-in hybrid is not the mainstream now in China. The pure electric vehicle is the biggest number now. And also on the other side, for the infrastructure side, we have over 8 million of charging stations now. This includes the DC, AC, and some others. And the increasing rate is over 67% last year. And also among them, I think in some huge cities, the public charging station is roughly 70% of them. I think this is also because the China is starting from promote the charging infrastructure starting from these big cities. And in these big cities, normally parking is some kind of issues for most of the car owners. So a lot of the new EV owner, they will use public charging instead of the private one. But in my personal point of view, I think in the future, maybe this kind of things will change, especially when when some small cities and the countryside will have when they implement the EVs, then at that time the private stations will increase significantly in the following years. So this China really have a pretty long journey for the EV. So actually we have roughly 4 stages or phases among almost 2 decades. So the very initial research were initially start, I think, later 90s last century and early 2000. So at that stage, I think some early research has been done, and a lot of private companies, state-owned companies, some research centers, university, they just starting from the LEV, which is the light electric vehicle, to do some tests. And then they skip the passenger cars, directly enter the bus, all these commercial vehicles, because at that early stage, there are some huge event, and the government encourage the companies to join this kind of event. Something like in 2008, we had Olympic Games held in Beijing, and during that time, during this huge event, a lot of pilot projects have been running there. But anyway, during this initializing stage, it's we a lot of technologies just at the starting point. It's not very maturing. For example, in terms of the charging infrastructure, at that time we do not have any standard, and the vehicle is using their dedicated chargers to do the energy supply things. And I think in the early stages that's not an issue, because almost all the EVs at that time it is a very small number, and it's only running in a very small area during some event, some pilot project, so it is not a problem. But after 2009, we noticed the EV will eventually go to our daily life, and people will use it as a personal transportation tools, and also the public transportation needs the public service. So at that time, we entered the phase 2 around 2009 to 2013. We call it the practice phase. At this stage, and we're starting to research something like some early research regarding the standards. So we are trying to align the charging interface, no matter AC or DC, and some of other technologies also try to be standardized at that time. And also the safety and interoperability issues are put on the tables, people trying to resolve some problem regarding this. And after a couple of years of development, we entering the next phase, which is starting from roughly 2013 to 2017. And during that time, some of the state-owned company like State Grid and the Potaview and some others, Southern Grid, they starting invest a lot of monies on building the infrastructure, not only in the big cities, but also along the highway. So I think starting from 2014, State Grid starting the construction of the infrastructure around several major highways in China. And that's really give a very strong signal to the industry that the infrastructure is ready, and where's the cars. So I think almost at the same time, the OEMs in China start to increase their investment, their research, and the production. A lot of EVs are put into the market, and so this number increased until it reached to 2018. I think at that time we noticed we already have a pretty big number, but some kind of technology still we need to enter in some maturing market, and also some of the technology need to be turned to the high quality development. So we call it something like outstanding phase. And also regarding the policies, I think my colleague will give some details introduction about the policies here. I just give some rough introduction about this. In China, I think during the different stages and from the different authority, including the central government, including the local government, and even from some industry, we have different kind of policies, including planning, the subsidies, and also some regulations for safety and interoperability, and also to encourage the innovation of technology, the pricing system, and the integration of all of them. So it's a kind of long term, we in the different time we give different policies to encourage the industry. So we do believe this kind of policies is a very good enabler for the industry, especially during the initial stage. So then I will give some other introduction about the technologies. So especially for the energy supply things. So first, I would just say, for now, in China, of course, the conductive charging is the mainstream of the in terms of the energy supply systems. So we in China we have just like other place in the world, we use AC and DC charging, and the AC charging. I think in the early stage, we also have the high power AC, which can up to 63 kilowatt power. And for DC, currently the most popular chargers around the world, especially for the public area, is something the power is from 60 kilowatts to 150, something like this. This is the most popular chargers at this moment. But in the meantime, high power DC, I think maybe you already know, becomes very popular in the passing several years. And now a lot of operation companies and even some OEMs, they plan to build the high power chargers in some public areas, some terminals, some airports, and some bus stations, something like this. And this power for now is starting from roughly 200 kilowatts to like 400. And I think also in the future, in my following page, I will also give some introduction about the so-called ultra high power charging. This is the technology prepared for the heavy duty vehicles at this moment. And maybe in the future, when the batteries comes to more maturing, then this kind of ultra high power will provide a super fast charging to the small cars, and give it something like 5 minutes for 80% of charging. That means 500 kilometers in 5 minutes. So that's already close to the oil refilling time. So that's the charging things. And at home, normally in China we are using AC for now, less than 7 kilowatts single phase, and this is the most popular chargers for the private scenario. And besides of the conduct. Initially starting from 2010, or roughly like this. At that time, maybe you heard there's an Israel company called Better Place. At that time he was the only guys to promote this kind of technology, and also starting from 2011 or something, State Grid also attached a very huge attention on this kind of technology, because State Grid believes that because the batteries inside the substations could be kind of energy storage source in the future. So I think State Grid invested a pretty large investment during 2011 to 2014, but unfortunately, we noticed at that time the battery is not ready, and also the price of the battery swap station is significantly high. So State Grid stopped to invest this kind of technology. But in the meantime, there are still some other companies still in favor of this kind of technology in China. The one of the representative is NIO. I think they already has built something like 2,000 battery swap stations in China, and also they start to deploy the battery swap stations in Europe at this moment. And their vehicle are all supported the battery swap station. And this is for the passenger cars, and to be specific, the private passenger cars. But anyway, this is NIO seems like it's the very small number of the companies who use this. They have very special business models on this. But for other companies, as I mentioned, they are still using the conductive charging, not the battery swap stations here. On the other hand, the battery swap is also becomes very popular here for the two-wheelers. In China, we also have a very huge number of the e-bikes and the e-motors. So this kind of vehicle, so the battery is smaller, much smaller, and in China, the logistics is very popular. A lot of people do the logistics things here. They use this. Here. And as I know so far, this similar things also happening in Europe and also in Southeast Asia, like Malaysia, the Philippines, and some other countries. But anyway, battery swap is just some kind of replacement here. And another usage for the battery swap technology is for the heavy-duty vehicle. Now in China, we have a lot of heavy-duty vehicle, especially for the mining and for some logistical purpose. They start to use battery swap technology because they have a very huge battery that's very difficult for them to charge within a very short time frame. And also they have a very fixed road to one point to another point, and everything can be expected. So I think the most con for this battery swap thing is standardization. It's very difficult to standardize, especially for the passenger cars. So that also makes this kind of technology, I think it's not very popular, but still there. This is the case for battery swap thing. And another technologies we use in the very beginning stage is wireless charging. I think back on 2013, 14, something like this, it was very popular, and a lot of OEMs invest a lot of money on this. But to be honest, until now, this kind of technology is kind of only exists in some kind of luxury vehicles. And I think the biggest issue for this technology is, the power limit to transfer the power. Using the wireless charging, we need a certain coil it's kind of antenna to transfer the energy. We need a certain size of the coil to transfer a certain amount of the energy for wireless charging. But, the size of the chassis of the vehicle, especially for passenger cars, is limited. So in this case, the power transfer for wireless charging normally is limited less than 11 kilowatts. And that will give a very huge limitations for the implementation of this. Also, the price of wireless charging is compared with AC charging is still higher. So it's only existing in some luxury cars. But some experts also think in the future it is a good companion technology with the autonomous driving system. So in the future, if the autonomous driving becomes popular, at this moment, maybe wireless charger is one of the good choice for this kind of technology, because there's no drivers there, and no one can plug the connector to charge the car. So wireless charging could be one option way for the future autonomous charging systems. But it also have the competitive technology. We call it autonomous automatic connection charging, ACD system. So ACD system, which means you can use the couplers, they can connect it automatically with the help, sometimes with the help of a robot or something, or some mechanical equipment to do this. This kind of technology is also researched in China, but until now, it is still not in the very early stage. But if this kind of technology getting mature, I think wireless will have a very strong competitive technology there. So this is for the wireless charging. And here are some pictures about the scenario, the applications here in China. You can see in the public area, home charging, and semi-public area, which means the office and some shopping mall or something. We normally use the AC, but in public area, the DC is the mainstream. So like I already mentioned, the charging power is reached to something like 120 and 150 kilowatts is the mainstream now. And then next one, I will give some introduction about some developing technologies. The first one is plug charge. So people now in China, most of the operation company charge their cars using an app to do the starting the charging, to do the payment, and also to identify the customers. But plug and charge becomes very popular recently. A lot of operation company trying to use this technology, so they will implement some ID systems there to identify the different vehicles and different chargers, and people no longer need any previous actions like scanning a QR code, open the app, do something. What they need to do is just plug the connector there, and the charging is starting automatically, and after charging, the payment will also automatically be done. And roaming is also one of the topics we are talking about, because now in China we have a lot of operation companies. People in their cell phone, they have different kinds of apps for the different kind of company. Sometimes it's not very convenient to do this. And the roaming, something like the roaming system for our cell phone. You can bring your cell phone, go to the United States, and still using your SIM card. But for EV, we use the similar concept to do this. So now we already prepare some standards to exchange this kind of information between the different charging service operator, and they can exchange the information, including the customer identity, the payment, and the metering things. So this kind of things is also we started to use in a lot of operation companies using this kind of technology. And another very hot topic is about the interaction between the EV and the grid. With the along with the increasing of the EVs in some of the area, especially in the some old residential area, the power capacity is not enough. Sometimes when you have several tens of the EVs charging simultaneously, the power could be shut down or have some issues there. So we're starting to use so-called orderly charging to regulate this kind of demands. So theoretically, we just collect some information from the grid side, especially the distribution network, to know the capacity of the transformers, and then we control the vehicle to charge something like one by one in some order to do this. So this is a very initial stage of the interaction with the EV and the grid. And in the meantime, bidirectional charging also called V2G, is very, very hot topics here. And the issues we are facing is how to resolve the energy interaction and the information interaction. So the charger is one direction, the discharge is for other direction. So we need to have a lot of regulations, standards for this kind of bidirectional charging. So this kind of thing is we are doing the standardizations and also some pilot projects running here. Also, the price is need to be set for this kind of activity, and by using the bidirect charging, the advantages are obvious. So we can charge the vehicle during the peak time of the grid and discharge we are charging during the valley period and discharging during the peak of the grid. Also, now in China, we are trying to replace the conventional energy, the coal, to the new energies like the PVs, the wind bind, etc. With the increasing of this kind of new energy, we were facing another problems is because this kind of new energy is not very stable, especially during the evening or some special time. The PV will gone, and sometimes even the wind is getting weak. And if you had the penetration rate for this new EVs entering a very significant number, then the grid will have a big issues. Sometimes the power is far more not enough to support the load. So by using the electric vehicle, which most of them, especially for the passenger cars, are parked on their parking lot during the evening time, so they can discharge the batteries which they charge during the daytime to give some supplement to the grid. So this kind of technology is also under development. We are running a lot of projects and testings. So this is really something we are expecting to can give some help, not only for the transportation, but also for the energy side. And then I will give some introduction about the next generation of DC charging technology. The code name is Chaoji. So actually, starting from 2016, when we released our second DC charging interface standards, we already noticed that at that time, even in the world, we have different kinds of the charging system. For example, in the United States, they have CCS1. In Europe, they have CCS2. In Japan, they have CHAdeMO, and in China, we have GBT. All these charging technologies, actually, they are trying to realize the similar function. All the technology I mentioned are done by each solutions, but the OEMs and the users were facing the different kinds of charger interface. This is something similar like what happened in cell phone. So you can think about back in 20 years ago, the cell phone have different kinds of chargers, different kinds of charger interface. So how about in the future, we can align the charging system into one? So that's some of the initial intention for us to research a new charging interface called Chaoji. So this project, like I mentioned, actually starting from 2016, and along these years, we have done a lot of works, including the initial research, the pilot project, and the standardizations. And actually, this project is kind of an international collaboration project. And now we have a lot of countries joined to this project, including Japan, Germany, Italy, Australia, Netherlands, Switzerland, Korea, etc. And we set up several working groups to research the different aspects of this technology, including the couplers, the compatibility, system safety, communication protocol, etc. And this is some of the domestic and international companies joined this project. And Chaoji can provide a very high power output, up to 1500 volts and 600 amps with cooling systems. So this is a phase one. The output power can reach roughly 1 mega. And also we designed the smallest the connector compared with the other solutions, and this is also a very flexible configuration. It can combine with the different kinds of AC system, make it something similar like CCS, but it is a dedicated DC interface only. So like I said, the intention to do this is to unify the charging interface into one. To realize this, the first things we need to resolve is the compatibility. So Chaoji, by using some kind of special design, they can compatible with the CHAdeMO, CCS, as well as the GV systems. So that means if a vehicle equipped with a Chaoji coupler, it can use 3 kinds of, maybe 4 kinds of the charging system to charge it. So that's, I think, the first condition that we need to have to, eventually we can go to the unified charge interface. So this is something like I said, the mobile phone system. Now you can see we are all using Type-C instead of different kinds of charge interface 20 years ago. So we hope by using some times, we can also do the same things for the EV charging. And besides this kind of features, Chaoji can also support very high power. We call it ultra high power charging. The charging power can higher than 1 megahertz, which to we already finished some tests in the laboratory. The charging current can up to 3000 amps. Here on this picture, 15,000 is, we already have the chargers ready for demonstration. And in the labs, we already reach the 3000 amps charging there. So this is some pictures, the test we are doing for this kind of ultra high charging system. And also regarding charging, the Chaoji project, we are running a lot of projects, a lot of OEMs, including domestic one and international one, join this project to test the technology of this. And also now State Grid has deployed the 6 higher highway charging for Chaoji along the Beijing to Shanghai highway. So we plan to use this kind of technology in the future. Okay, so then we will go to my last section. It's about the standardization. So so in China, I think it's something unlike the other countries. So we have pretty complicated standard systems, and it is domestic by the government and also by the market. So for the government level, we have so-called the mandatory national standards, recommended national standards, and also we have recommended industry standards, and some of the local government also will release their local standards in some of the province. And for the industry side, we have group standards and also the company standards. So this kind of standards are strongly related. They have different layers. So, for example, for this mandatory national standards and the recommended national standards, more or less is regarding the safety and the system interface. For the industry standards, we mainly describe the equipment level. And for groups standards, is for this new technology, something like I mentioned, plug and charge and roaming. This is all starting from the group standards. And also some company has their own standard like StayGrid, but this is more or less for the quality of the product. And in terms of the charging infrastructure, in China, we have the different kinds of starts in the technology aspect. So we have terminology which will define all the terms, which is personally I also think this is very important. So if same things will have several names, people will get lost lately. So this is a very start point of every new system. And also we have the information safety and the identification of the different system. And for technology things, we have energy transfer standards, service network, and also for construction and operation, we have the relevant standards for this kind of all these kind of things. So by now, I think we already have more than 31 national standards and 21 industry standards, which are all about the charging systems. So this is some typical standards we just released. This CHAOJI is also inside these national standards, which is GBT 18487.1, 27930, and 20234.4. And in the meantime, we are not only focused on the domestic standards, we are also very active in the international level. So in IEC, there are two technical committees, TC69 and IC23H. These two technical committees are preparing the standards for charging systems, TC69, and SC23H is mainly prepare the standards for the charging couplers. So China is very active in these two committees. We already set up several ad hoc groups there, and also some working groups for different kinds of charging standards, battery swap standards, and roaming standards. Also, CHAOJI is also inside it. And for now, until now, we already released 9 international standards in IEC, and including 8 international standards and 1 technology report. So this is all convened by China. China is the convener of these groups. These standards including, just like I mentioned, the charging roaming, the battery swapping, and some of the charging systems, including the couplers. So I think this is also very important to bring this kind of technology to the international level, so that I think today's meetings is also, we want to give them information. The standards is now it's already international level. It is easier for us to to stay on a common platform, especially in terms of the safety and interoperability. The international standard is very important. So let's come to my last page, which is the conclusion. The development of the new energy vehicle and infrastructure in China actually is a very long-term process. It's not only within several years. We started this process starting from almost 20 years ago, and after a very long time of research, and we have something for today. And the policies is very important, and China released a lot of policies in the different stage and guide the direction of the industry development and ensure the healthy growth. And also they actively explore the various technologies to promote the scientific development of industry. This is also very important. So during these years, we tried a lot of technologies, and some succeed, some is not very good. So we tried a lot of things, and in the end, we found our own way. And Also, standardization is very important for the technologies. So to ensure, especially to ensure the safety bottom line, and also the interoperability, we need the standards to standardize to save the cost of the of the industry. And in the end, we will have a very good quality product and also the low cost. Okay, that's the presentation from my side. Thank you very much for listening. So I will give the stage back to the Jill. Thank you.
Thank you very much, Mr. Ni, for the excellent presentation. That was very, very rich in terms of information and knowledge. Thank you for presenting it in a very integrated package that covered all the aspects. So thank you very much. I will move on now to the second session of today's webinar, and I remind you that we will take all your questions at the end. Second session of today's webinar is on the market policy enablers. And for this session, we have with us Ms. Ran Ji. She's a project manager at Automotive Data of China Company Limited. Ms. Ji has been engaged in long-term research on energy conservation and new energy vehicle industry policies and technologies. She participated in research on multiple major management policies, industry plans, and industry roadmaps in China's automotive industry, including research on the dual credit management policy for passenger car enterprises, as well as the development plan for the new energy vehicle industry 2021-2035, the green and low carbon development roadmap for the automobile industry, the energy conservation and new energy technology roadmap 2.0, and the key technology roadmap for China's manufacturing industry. Ms. Ji, the floor is yours. If you could please unmute yourself, turn on your video, and share your screen.
Okay, thank you for your introduction. Can you hear me?
Yes, we can hear you and we can see you on video.
Okay, I will share my slides.
Please. Yes, we can see you.
Okay, so I will start my presentation. Hello, everyone. My name is Jiran. I'm from Automotive Data of China, and I'm honored here to share our team's latest research on China EV market and policy. So before my presentation, I want to have a brief introduction of Automotive Data of China and also our research team. So Automotive Data of China, also abbreviated as ADC, is a subsidiary company of China Automotive Technology and Research Center, which is abbreviated as CADARC. Our headquarters is based in Tianjin, China, and we also have some research teams working in Beijing, China. So ADC is a third-party research institution. We focus on research in energy conservation and low carbon, automotive market, and intelligent connection. And our unique advantage lies in data resources and distinctive models of the automotive industry. And I am from the Product and Technology Strategy Department of ADC. So this is a brief introduction of our team. Our research team consists of research groups focusing on policy, market, technology, and product. And this is also what differs us from other research institutes, that we pay more attention to the interactive impact research of policy, market, technology, and product. On one hand, we have been supporting national authorities on energy conservation and new energy industry management research. And on the other hand, we provide consulting service on product and technology planning strategy for vehicle cooperates. So now let's come to our main topic today, and there are three parts in my presentation. Before the discussion of new energy vehicle policy and market, I want to share a brief introduction of overall passenger vehicle market situation in China. And after that, in the second chapter, we will see how will the new energy vehicle policy management system evolve in the future. And then in the last chapter, we will discuss the situation and also opportunities of new energy vehicle market in China. So now let's come to the topic of overall passenger vehicle market first. Here we want to shed light on the question of how will the overall market go in the next 3 to 5 years in China. So to answer this question, we will have a brief look at the macroeconomic environment in China and also the industry cycle to see if there is a hint of future market situation. And after that, we will introduce three aspects of new market growth momentum we found in our analysis. So let's begin by the relationship between vehicle market and macroeconomy circumstances. As we know that cars have always been seen as important consumer goods, so it's not hard to imagine that there is a positive correlationship between vehicle market and macroeconomy growth. And this rule can also be double-checked by the historical data. As we can see on the slides, the GDP curve and passenger vehicle market growth curve, they share a parallel trend, not only in developed countries such as in the US and also in Japan, but also in developing countries like China. But apart from consumer goods, vehicle industry is one of the pillar industries in China. And that means some counter cyclical adjustments will be made to the vehicle industry to boost economy under pressure. So looking back at history, we can see some pro-consumption policies. They were implemented in the crucial years with little or no growth. And the policies surely paid off, but we can't deny the fact that the moderating effect is weakening. So, in conclusion, in our analysis of the relationship between macroeconomic environment and vehicle market, we think macroeconomy circumstances play a vital role in supporting vehicle market growth. As macroeconomy will go through a modest recovery in our prediction, we think the domestic vehicle market in China will also be growing steadily without a dramatic boom in the next 3 to 5 years. And next, let's come to the industry cycle. And there is a consensus on the industry development that there are 6 main stages of startup, growth, mature, integration, harvesting, and decline. So it is a national strategy in China to develop new energy vehicles. And now more and more OEMs, they are participating in the China market with ample supply of excellent models. And new energy vehicle industry is getting close to the beginning of mature stage in our research. And it was marked by fierce competition with low profit of market share. But in contrast, for the situation of internal combustion engine vehicles, the market has already reached the ceiling and has gone through several years of decrease in China. So we deem that it is now in the beginning of the decline phase. And a price war extend to the whole market, and the outdated capacity will gradually exit. So from the perspective of macroeconomic circumstances and vehicle industry cycle, it can be seen that domestic vehicle market will go through a fierce evolution. You may wonder if there is some new opportunities in the market, and we found 3 structural growth areas that can be strong momentum to support vehicle market in China grow steadily. And the first is that additional and trade-in purchase will become the new source of growth instead of first purchase in China. So as we know that the population in China has already peaked ahead in 2021, and the demographic changes will provoke the decline of first purchase group scale. And additionally, judging from the car park structure, vehicle with the age of 4 to 9 years exceeds 110 million, which can be potential group with additional or trade-in purchase needs. So in conclusion, as the population and additional and trade-in purchase, consumers will be the mainstream buyers in China instead of first purchase consumers in the next 3 to 5 years in China. And secondly is that new energy vehicle market is under fast development in China. In contrast with internal combustion engine vehicles, new energy vehicle market has been under fast development in China and has been the largest around the world since 2015. While in the new energy vehicle market, the increasing speed of PHEV has exceeded that of battery electric vehicles since 2022. So this is contributing a key growth for new energy vehicle market. And the third one is the car export. You may know that in 2023, China is expected to surpass Japan to become the world's largest vehicle exporter with a vehicle export scale of 4.91 million. So the boom of China vehicle export is due to multiple factors. Firstly, the domestic demand is insufficient, impelling the domestic OEMs to search for new opportunities overseas. Secondly, China has been active in expanding global trade partners. And last but not least, we have seen great improvement in the product competitiveness of vehicle made in China. And equally important is regulations overseas will be tightened, and political and trade risks will always exist for China OEMs. So how will China vehicle export grow continuously in the future? And to answer this question, we think China vehicle export is now in the stage 1.0, focusing on trade export with deepened cooperations with partners overseas. In the future, more local plants will be built by China OEMs overseas, and OEMs and also component manufacturers will jointly go overseas to build industrial clusters to furtherly reinforce competencies. Now let's quickly go over the main point in the first chapter. So as the macro economy will be steadily growing and the whole market, vehicle market, will be under low profit competition state, we think the domestic vehicle market, especially the domestic passenger vehicle market in China, will be modest recovering in the future with fierce evolution inside. And we found 3 structural increasing points in the vehicle market, that is, first, additional and trade-in purchase, second, the new energy vehicle, and last, the vehicle exporting. And before we move on to the situation of new energy vehicle industry, let's have a brief review of the development process of China's new energy vehicle industry. Since the start of pilot demonstration of promoting 1,000 new energy vehicles in 10 cities project in 2009, China new energy vehicle industry has gone through 3 stages. The theme of first stage is policy support. Demonstration applications were carried out to lay the foundation for large-scale promotion. And in the second stage, new energy vehicles are gradually promoted to public, and the whole industry chain were also incubated. And in 2021, we can see a significant improvement in new energy vehicle market penetration and two-wheel drive stage got started. And this two-wheel means both policy and also market. So in terms of policies, the guidance of new energy vehicles were taken over by dual credit policy in China, which means pushing more OEMs to produce a variety of excellent new energy vehicle models. And in terms of market, we think new energy vehicles are increasingly accepted by consumers in China. And in the next 2 chapters, we will see the situation and also development trend of policy and market of new energy vehicles in China. So the strategy of developing new energy vehicles is based on the dual carbon strategy, the energy security requirements, and also the Beautiful China strategy. As for the dual carbon goals, the carbon emissions generated by transport sector has reached 12%, and 90% of them are contributed by vehicles in China. And as for the energy security, China's oil dependence on foreign countries has reached 70%, and more than 80% of gasoline and diesel were used by vehicles. And for Beautiful China strategy, a 45 penetration rate of new energy vehicle in 2027 was set as a concrete goal. And also, the popularization of new energy vehicle is effective for gaseous pollutants emission reduction. So, in order to guide the new energy vehicle industry development, a policy system has been set covering the key sections of vehicle life cycle, including research and development, access and production, purchase, aftermarket, and also the related field, such as infrastructure. So the policy with the industry developing, the policy management is continuous improving. So in the next section, I will introduce the latest relevant changes in the policy system in China. So as for the top-level design, CADARC and SAE China did the research work on Roadmap 1.0 for green and new low-carbon development of automotive industry in China, and it was finally released at the end of 2023. So in the research, we can see the carbon emission accounting boundary of automotive industry were first clarified for the first time, and the automotive utilization is the most important section for carbon emission reduction management in China. And by path of fuel conservation and also new energy vehicle popularization, we can get a carbon emission variation curve of passenger vehicles. and we can see that the carbon emission will decrease by 95% on 2060, reaching a near zero carbon emission goal in China. And in terms of research and development section, 3 verticals and 3 horizontals layout has been put forward to guide the direction of technology development of new energy vehicle industry. So the battery electric vehicles, the plug-in electric vehicles, and also fuel cell electric vehicles are all set as strategic technology routes for new energy vehicle strategy in China. And also some key field related to electrification and intelligence were chosen for new energy vehicle strategy, including power battery and management system, the drive motor and power electronics, and networking and intelligent technologies. So the balanced technology route setting and also precise technology field identification, they all contribute and laid a solid foundation for new energy vehicle industry development in China. And as for the access and production section, I want to talk about the dual credit policy in China. And our team has been supporting MIIT on the policy research since 2014. So the dual credit policy was first released in 2017, and 2 revision was released subsequently. It has been a world first management policy on the energy conservation and new energy vehicle guidance. And through the guide of dual credit policy, the planning goals for energy conservation and new energy vehicle were reached ahead of time in China. And at present, our team is focusing on the policy revision for the next stage of 2026 to 2030. And new goals will be set, and high quality development of new energy vehicle industry will also be one of our top concerns during the policy making. And as for the purchase section, the subsidy surely played an important role in the early days of new energy vehicle market, and it was officially withdrawn at the end of 2022. Yet 2 kinds of supportive policy will also have positive influence on the new energy vehicle popularization. First is the purchase tax reduction policy. It is now extended to 2027. The eligible models will enjoy a full exemption in 2024 to 2025 with an upper limit of 30,000 RMB and a 50% reduction in purchase tax in 2026 to 2027 with an upper limit of 15,000 RMB. And the second is that several guiding policies for specific areas were released, such as popularization in countryside, public application, and the demonstration and the application of FCEV and battery swapping. So these policies, they are aiming at searching for flexible and effective guiding mode for specific area application. And next, let's come to a segment highly related to new energy vehicle development, that is the charging infrastructure. So in the early stage of the industry development, we can see that the growth rate of new energy vehicle market is significantly higher than that of infrastructure building. And afterwards, the growth rate of new energy vehicle went down, and the charging infrastructure building got accelerated. And in recent years, the promotion of new energy vehicles and the charging infrastructure construction speed basically matches with each other, and a high quality development of the infrastructure system is the next goal for China. And finally, let's have a short conclusion on the new energy vehicle policies in China. As we can see, policy has covered nearly all the key sections of new energy vehicle industries, and also the guidance of market scale and technology developments are all included. So in general, we think there are 4 major effects through policy guidance. First is that the scale of new energy vehicles grew rapidly. Second is that the energy conservation and carbon emission reduction got significant progress. And the average fuel consumption data here is needed to update it. And third is that there emerged a bunch of national brands and featured products in China new energy vehicle market. And last is that technology levels of new energy vehicles got significantly improved. So in the last chapter, we will have analysis on China new energy vehicle market and see if there is any new market opportunities that can be found. So let's see the latest market data first. The growth rate of new energy vehicles has maintained high in 2023, except for January, which is related to the Spring Festival holidays in China. And also, in contrast with internal combustion engine vehicle market, we can see that the new energy vehicle sales increased by 39% year on year, leading to an increment in overall passenger vehicle market sales in 2023. And also the penetration rate of new energy vehicle sales in China reaches 33.5%. And now let's look at the situation of separate technology routes in new energy vehicles. We can see that the battery electric vehicle sales volume increased by 24.2% in 2023 compared to 2024, while the growth rate of PHEV, plug-in hybrid electric vehicles, is as high as 85.1%. So the PHEV market is going through a period of rapid growth in China. And in the previous parts, we have seen splits in growth speed between new energy vehicles and internal combustion engine vehicles, and also among different technology routes in new energy vehicles. And here we want to introduce our findings of penetration splits in different segments. So we can see a continuous growth in new energy vehicles in the last years, but the growth rate is decreasing in 2022 to 2023. So it is not hard to understand that a continuous high-speed growth is not sustainable in the market. So we need to break down to market segments to see which part is promising for future growth. And it can be seen in the right curve that the penetration rate varies in different market segments. Some segments like A-class and B-class exhibit low energy vehicle penetration. And the underlying reasons we think is that different technology routes has their own advantages, and consumers have various priority concerns for each segment, and thus bringing about penetration variety in different segments. In the next section, we will see the situation of different segments. In terms of small cars, such as A00 and A0 class, the market situation is fairly different. For A00 class, the electrification rate is nearly 100% in China, while the sales volume has reached the ceiling of around 1 million. And for the A0 class, we see an inflection point coming with an increasing new energy vehicle penetration. So this is due to the changes of supply, demand, and policy. So concerning the supply, we can see that the amount of new A00 class models is decreasing, while that of A0 class models is increasing. And also our calculation indicates that the total cost of ownership for battery electric vehicle route in A0 class will deliver a higher advantage in the future due to mature technologies and also decreased battery prices. And for the battery of demand, we can see there is an overlap between the price ranges of A00 class models and A0 class models. So consumers tend to choose A0 class models with a larger size in that situation. And last is about the policy influence. So as we mentioned before, new energy vehicles enjoy a purchase tax reduction in China, and the revised purchase tax reduction policy came up with a higher technical requirements of E-range and also battery energy density, and that exempts a lot of A00 class models from the policy preferential, so that's impairing their price competitiveness. And now let's come to the situation of A class. So A class is now still the largest segment in sales volume in China passenger vehicle market. But the penetration of new energy vehicle is below average, especially in the private usage market. And in our calculation, we can see that the total cost of ownership of battery electric vehicles of A class shows advantage in short term. So that is boosting the PHEV blossom in A class market. While in the long term, we think battery electric vehicles will still gain advantage over other technology routes in total cost of ownership. And for larger cars, such as B and C class, the sales volume is gradually increasing, driven by consumption upgrading and increasing in additional and trade-in purchase needs. And the corresponding new energy vehicle penetration rate is approximately equal to the average level of passenger vehicle. So we think the key technology innovation contributes a better user experience and will help to boost new energy vehicle popularization in B and C class segments. And for PHEV models, the key is to optimize the driving experience. Sharing platform with battery electric vehicles is one of a good choice. And for battery electric vehicle users, the performances related to convenience is one of their top priorities. Such as solid state batteries that can bring about longer E-range and also high voltage platform that improves charging speed, they will both help to meet consumers' needs. And finally, let's make a conclusion on this chapter and on the whole presentation. In this chapter, we mainly analyzed the new energy vehicle penetration in different segments market to see if there is some promising increasement part in the future. And we think that we are now at the end of electrification 1.0 era in China, when small segments such as A00 and A0 class mainly contributes to the sales volume. And in the next few years, we will see the electrician era 2.0 coming. And in this area, in this era, A or B or C classes, which are also the mainstream market segments in internal combustion engine market, vehicle market, they will mainly contribute in the sales volume for new energy vehicles. And this is driven by excellent and lower cost PHEV models. And in the middle and long run, around 2030, so when the total cost of ownership of battery electric vehicles will show advantage comprehensively, we can see the electrification era 3.0 in China starts. And that's when battery electric vehicles will compete with PHEV models in the market for more market share. And that's all my presentation today. And all the related questions are welcomed later. Thank you all.
Thank you very much, Ran, for the super informative presentation and information, very comprehensive in terms of policy and macroeconomic environment variables. I think it's safe to say that Mr. Ni and yourself took us on a beautiful electric ride in across China. And now we're going to travel to Jordan to learn more about the Jordanian experience from the Arab region. With us this morning, we have Ms. Bushra Fahad Al Falah. She's the head of Energy Sector Planning Section at the Ministry of Energy and Mineral Resources. Ms. Al Falah holds a bachelor degree in Power Electrical Engineering from Al Balqa University in Jordan and a master's degree in Management and Strategic Studies from the National Defense College in Jordan. In 2002, she joined the Ministry of Energy and Mineral Resources as an electrical engineer, and in 2014, she held the position of Operation and Services Development Section Head and was nominated to be a member of the CIGRE Technical Committee. And finally, in 2019, she became the head of the Energy Sector Planning Section. Ms. Al Falah, the floor is yours. I need you to please turn on your audio and your camera so we can see you and hear you. Please.
Thank you, Will. Thank you for your introduction. Hello, everyone. As mentioned, this is a fruitful webinar that the transition to electric transportation holds a significant importance in enhancing the safety and the reliability in the electrical sector. It's also play a crucial role in parallel effort to reduce the carbon emission. It's noteworthy that one of our goals in the Jordan energy sector strategy is to achieve 10% reduction in carbon emission by the end of 2030. During our work on preparing the energy balance of Jordan, it became evident that the transportation sector plays a significant role in the green gas emission. That data indicates that the transportation sector consumed approximately 43% of the final energy consumption in the 2022. This necessitates intensified effort to streamline energy consumption in this sector and enhance energy efficiency. NEMAR took a significant role in advancing EV agenda by establishing a high-level committee for encouraging the expansion of electric transportation. The committee serve as a central hub for strategic decision-making and policy formulation and coordination the efforts aimed at promoting the widespread adoption of electric transportation by united representatives from key ministries and regulatory bodies. Last 5 years, several obstacles hinder the speed of EVs. First, the inadequate infrastructure. As you know, that the widespread availability of charging stations is essential for the practical adoption of EVs. Secondly, the insufficient investment in this sector for both public and private entities looking to invest in EVs. And lastly, the shortage expert and knowledge in managing EV. In line with the Jordan Energy Strategy 2020 to 2030, MEMR initiates the implementation of the EPB street goal by taking a proactive role in overseeing and coordinating the mapping out of all studies and the projects carried out in Jordan by various donors in the field of electric transportation over the last 5 years. This strategic step was taken to ensure a comprehensive understanding of the existing landscape and prevent redundancy and avoid the unnecessary re-implementation of the prior initiative. In this context, efforts are underway to formulate a study on options of EV strategy, which the ministry is working on implemented with the support of the World Bank in collaboration with the technical team from various entities in the energy sector. The purpose of this study is to explore the required infrastructure options and incentives needed to encourage EVs in Jordan. And the study aims also to assess the impact of charging station on the electrical grid. And lastly, to explore a tariff option in this regard. This study will launch at April 2024 and start to implement the recommendation after that. After we start to have a study to promote using EV, suddenly in the fourth of the quarter in the previous year, there was a rapid and sudden increase in the number of EVs has risen from 0 in 2014 to approximately 16,000 by the end of the 2023. And the number of the license for the public and the private electric charging station has reached to 68 stations across the kingdom. EMRC has issued an approval for the installation of electric vehicle charging meter in homes reaching 3,000 of approval. The aim of this meter is to transfer citizens to the Cape meter with a fixed tariff and not to use the home meter with a signal tariff, as I will clarify later. This surge in number of EVs may be one of the reasons that contribute is the rise of the fuel price, which has made EV more economically attractive. Consumers are increasingly turning to this vehicle and as a strategic choice in operational costs and diminish their dependence on the traditional fuel. Another strong reason that supports the transition to EVs is the modification of electricity tariff and the support of household meter. This initiative aims to reduce the cost of electricity, leading consumers to opt to the charging their electric vehicle directly from the household meter. This behavior has contributed to an increase in household consumption value, which had an impact on the study's analysis. Consequently, EMRC imposed a license on electric vehicle meter that the tariff from this meter is cheaper than the household meter, and it is a fixed rate and doesn't depend on the consumption segment, unlike the household meter. On the other side, EMRC has also implemented time of use tariff for charging stations. This approach encourages electric vehicle owners to charge their vehicle outside peak hours, benefiting from the lower tariff avoid the risk of peak load escalation. Furthermore, commendation should be given to the effort of the EMRC in overcoming barrier to investment in electric transportation. This has been achieved by increasing the electricity tariff for charging stations to approximately 8 and 5 fils per kilowatt hour, aiming to enhance the return on investment in the field and stimulate investors to participate. It's important to note that the custom tax rate on electric cars doesn't exceed 15 according the size of the motor. Finally, as for renewable energy, which account for 27% of the electricity generation, it stands as a pivotal factor contribution in the growing of adoption of electric cars. This trend is particularly evident among the homeowners who choose to install renewable energy system in their rooftop. This is what I have today, and I am ready for any question. There is a presence from the Jordan side and from the energy sector entities and the member of the e-mobility action study, as I mentioned, if they have anything to add. Thank you.
Thank you, Ms. Bushra, for the overview in Jordan. And I'd like to quickly confirm something you mentioned about the cost of electric vehicles. Radia and I were on a mission to Jordan last year, and most of the Ubers we took were electric vehicles. And all of the drivers, we were so impressed by their knowledge of the workings of the vehicle, the savings, the emission savings. And they kept saying that to charge a vehicle and drive it electrically in Jordan, it was 75% cheaper than using a gasoline vehicle. So we actually ended up doing the math when we got back to the office, and it was actually true. So that was very good to be able to confirm and to see it unfolding in the Arab region. So thank you very much for that. We're going to move on now to the Q&A session that I'm going to initiate now. We had one raised hand by Mr. Ali Sayed. Mr. Ali Sayed, I'm going to ask you to unmute and I've asked you to unmute, if you could please, Mr. Ali. Or you could, okay, your microphone is open.
Thank you. My concern only is, I would like to know if China is also preparing its infrastructure to eventually safely dispose electric batteries in the future.
Okay, thank you for your question. Is this something that Mr. Ni can answer, or Ms. G? I'll leave.
I'm sorry, I think I haven't got the question very clear.
Go ahead.
Safety of the battery or something?
He was asking about the safe disposal of the batteries when they're end of life.
Okay, so that means the second life of the battery. So I think in China we have some of the researchers also researching this area, and even as I know so far, some of the standards is as under preparation. That after the there's two possible ways to this kind of the second-hand battery, I would say. One is go to the energy storage systems. So some of the batteries, when they use inside a vehicle, the capacity reached something like 70% or something. The vehicle will no longer use this. And okay, I will turn on the. Okay, but but it still can be used as a energy storage batteries. So some of the companies are doing this, And also, if the battery is totally it's depleted and it cannot be used anymore, there's some kind of procedure to do this for the recycling things. But to be honest, I'm not the expert on this area, but I know something is done there. Someone's doing this. So if you're interested in, maybe I can check this for you. Okay.
Yes, that would be actually very beneficial if you could get back to us whenever your time allows on this, and we would obviously share the information with all the participants.
Thank
I'll
you.
move on. Thank you. I'll move on now to the second person with a raised hand, Mr. Ali Dimasi. I've asked you to unmute, so please do so, and you can ask your question. Please.
Okay, thank you for this webinar. First of all, in their 2022
Mr. Ali, we lost you. We can't hear.
titled Land Electric Mobility in the Arab Region, the UN ESCWA states reportedly declined employment.
Mr. Ali, your connection cut out, so we weren't able to hear anything, and then we heard everything very.
Opportunities due to the lack of accessible of electric in Jordan be considered a potential solution to reduce or even lower this percentage.
Mr. Ala, can you hear us?
Yes.
Okay. Mr. Ala, your connection is cutting out, so we're not being able to hear your question. Can you please type it in the chat box? I will read it and we will have it answered, please. Thank you. I'll move on to the next person with a raised hand. Mr. Daniel Aboud, I've asked you to unmute. If you could please ask your question.
Good morning, and thank you for this presentation. Very informative. There has been a lot said about the charging side, not very much said about the energy storage side. I am wondering if in China they are considering at all storage with things like hydrogen fuel cells, for example, instead of standard batteries. Thank you.
Yeah, I think I can take part of this. You know, I'm also not a very expert than this kind of energy storage. But as I know so far, there are different kinds of energy storage technology under research and also deployed for testing purpose. But now the mainstream in China is except all these traditional energy storage like the hydro stations. Now people more or less focus on the the battery systems. I think this is one thing it's very popular out here. But in the meantime, we have other kinds of storage systems like mechanical things, and this is also on the research. And I haven't heard there's a very mass deployment for this kind of technology so far. Now, yeah, besides the traditional one, I think the battery storage is the most popular one we currently use.
Thank you very much, and I hope the question has been answered. I'll now read the question on behalf of Mr. Ala Dimasi, who had audio problems. His question states, and I believe it's directed to Ms. Bushra. The question says, in their 2022 report titled Land Electric Mobility in the Arab Region, UN ESCWA states that 40% of surveyed women in Jordan reportedly declined employment opportunities due to lack of access to viable transport. Can the increased adoption of electric vehicles in Jordan be considered a potential solution to reduce or even lower this percentage cost-wise? So it's clear that women are not being able to take on as many employment opportunities as they need due to a lack of transportation. Ms. Bushra and I believe Ms. Radia can chime in on this. Ms. Bushra, the floor is yours. You could unmute yourself and speak, please.
Thank you very much. I think there's a huge potential when we speak about the electric vehicle uptake in Jordan. And however, I personally, from ISCO perspective, we couldn't see it yet addressing the urban-rural divide. Specifically, we've been implementing a renewable energy project in rural areas in Jordan. And we have seen when we take the different pillars in terms of women empowerment, job creation, entrepreneurships, and looking the policy as enablers, we could see perfectly that the mobility is a real constraint for women to market their product and reach the market independently if they have access to energy at the level of household or where they have the cooperative businesses. So I think as a second step, since Busha did mention in her intervention that they study in 2024 where the recommendations would be released and used as a basis for expanding the use of electric vehicle, if we can be involved in a way as a peer reviewers in order to see and build on the experience that our colleagues from in China did present the business model in a way to see how we really take into consideration not only the gender perspective and integrated within the economic and social development, but more importantly also to take it from an opportunity for climate finance, if I may say, specifically that speak about infrastructure development at the outset. And number two, maybe is also to see it from the car ownership in a way to see the youth and how to use the opportunity of growing population in a way to also mobilize them for this purpose. Thank you.
Thank you, Radia, for your answer. I believe this is very clear, and Mr. Ala Dimasi in the chat box thanks us for the answer. Before I move now to the closing, I'd like to remind you please to stay with us until the end because we have to take a group photo so everyone can appear with their camera turned on. So please stay with us until the end. And now I will give the floor to Dr. Cheng from GuideCo to start the closing remarks.
Can I have one question, please? Sorry, because I raised my hand.
Okay, sorry, we didn't see it. Mr. Rabeh, please, the floor is yours.
Yes, thank you very much for this great webinar. Just I have one question. Actually, we have a big challenge in Palestine that the Palestinian government try to have some incentives to prompt electric cars in Palestine. But meanwhile, 70% of Palestinian public revenue comes through tariff and taxes on cars and fuel, actually. So I would like to ask where the government can find the balance between prompting electric cars and meanwhile less dependent on importing fuel from Israel, and in the same time keep the public revenues not decreasing sharp.
Thank you for your question, and I believe Ms. Saddawi will take this one.
Thank you very much, Gilles, and thanks, Rabah, for your question. And certainly, we cannot consider, as we did state at the opening, that it needs to be an integrated approach and multidisciplinary when it comes to how we address the electric vehicle and electricity to move, let's say, address the issues of mobility. I think the business model presented, be it for Jordan and China specifically on its expanding market, they did present for us certain enablers in terms of looking how the government, which has the resources in terms of investing in the infrastructure and give a market signal, and then basically put in certain subsidies to support the market. And obviously, different business model might be divergent. At the end of the day, it depends on the enablers, and the enablers among them to have peace and to have energy as a source of peace, specifically in the case of Palestine, and given the issues of energy security and ongoing conflicts, and this certainly is a challenge not only for mobility but also access to electricity and clean cooking. And obviously, whatever government institution would try to put in place in terms of invest in infrastructure, there are other challenges that are unfortunately putting burden in this development, not only in Palestine, but in any country facing conflict situation and wars. And obviously, this is certainly a situation for consideration when it comes to looking how the right for development, economic and social development is also need to go hand in hand with access to science technology, but more importantly with peace. Thank you.
Thank you, Radia, for the answer. And if no other questions are remaining, I will move now to give the floor to Dr. Chang. And for those who joined midway through the webinar, please switch to the interpretation English channel in Zoom. So switch to the English channel so you can listen to the interpretation in English. Dr. Chang, the floor is yours, please.
好，最近的各位来宾女士们、先生们，特别是今天联合国西亚经社委的2位领导的付出的努力和辛苦，表示感谢。也很高兴我和大家一起参加了由联合国西亚经社委和全球能源互联网发展合作组织主办的培训活动，衷心的感谢各方为此次活动做出的努力和大力的支持。本次培训呢，以中国电动汽车市场发展经验为主题，通过分享中国电动汽车发展的成功经验，为阿拉伯地区的电动汽车的发展提供参考和借鉴。我相信呢，通过此次培训，以未来的合作，全球能源互联网发展合作组织将继续与各方一道深化合作，携手推进西亚北非地区的能源互联和全球能源互联网的建设，为西亚北非地区的能源转型和人类的可持续发展做出积极的贡献。在此，对本次活动的培训取得的圆满成功表示衷心的祝贺啊！谢谢大家。
I believe we had a technical issue with the interpretation. The English interpretation was not being heard on the English channel. So for the interpreter responsible for this, please switch to the English channel for the English interpretation and not the Chinese one. Please. No problem, we can hear you. Please, because we couldn't hear anything. Please.
啊，我再说一下吗？这傅凯再念一下。
Yes, yes.
傅凯，你再念一下，他刚才好像没听见。
再念吧。再念吧。傅凯直接在中文频道念。
Thank you very much, Dr. Chang, for your closing remarks and for the interpretation. And I'll give the floor now to Radia for her closing remarks, after which we will take the group photo. Thank you.
Thank you very much, Dr. Chang and estimate speakers. Honestly, it's more than what we expected. The insight from the experts both were extremely relevant, and I couldn't myself stop following very carefully each of the presentations. And I believe this is just a starting point on continuous collaboration that we have with our partner organization, JADECO. A really amazing job that is done in China. And this just reminds me in 2006 when I was a young engineer in studying in Oxford, and we had to do a business model looking to the case study of China evolving market in the energy sector, and specifically on the electricity. And people were impressed. Some of them were a little bit surprised or not expected the presentation at that time when we did present, saying that the energy sector in China, specifically electricity, will be really competing with petroleum product and will really lead the market and lead globally when it comes to the e-mobility. And this is thanks to what was, I think, just confirmed by the speakers, looking to the phasing approach strategy that was adopted, as presented, also looking to how the government gives signals, like what was done back in, I think it was presented when we have seen the curve, 2009, and then how it's evolved since 2013, 2017, specific how government give us signals in terms of building the highways, the infrastructure, and this is how the industries across different providers, be it for batteries, be it for electric vehicles and others, all what's the kind of, I would say that the different aspect of technology and the investment that were needed. And impressive how also the government give a signal when it comes to the looking what was present in the economic enablers, looking obviously how the different generations and population in China, how the growth, the economic growth coupled with the e-mobility aspect, leading to different aspects. I think what I just took note in terms of dual carbon goals, energy security, and beautiful China. And this certainly was, I would say, for me, I see it a very strategic strategy, integrated, honestly, in a way that it shows the China commitment to address climate change, but more importantly, the right of economic development and the role of China leading in this sector. What we have seen as the forecast presented by the expert, how China would even overtake in terms of export electric vehicle by 2030 and by 2060. Certainly, as presented, also the leadership, the top management commitment, and more importantly, also some of the enablers, how market signals is also linked to different kind of subsidies, like this purchase and first purchase cards subsidy that was implemented, and how the phasing out in terms of tax reduction, and how this is somehow link it to how the market is evolving, how the technology is evolving, and more importantly, how the uptake in the domestic market and potential for export. And what I like it the most is also the international collaboration and the different projects that were presented, looking that China is really helping to make electricity the fuel of the future, and how this obviously would contribute to sustainable development. I just want to add something, if my colleague Jill allowed, to say that maybe one of the things that I would have loved to see, and maybe in the next capacity building, is the upstream side of the equation. China leading and others in the electricity market, specifically in EV, but we all know that we will and continue to struggle in looking to the demand, supply, demand balance when it's come to the minerals and critical raw materials needed for this transition and for electric vehicle and electric batteries. And this obviously needs to have much more regional and international collaboration. And we value our collaboration with JADECO, and continuously we would like also that we drive on this experience in order to see how collaboratively we can address this bottleneck and ensure that we all develop, maybe in different pathways, but we all achieve the targets by 2030, or to be realistic by 2050 or 60. Thank you very much, and over to you, Jill.
Thank you, Radia, and thank you, Dr. Cheng, for your closing remarks. And I'd also like to take the opportunity to thank JADECO for their support, collaboration, and their input in today's webinar. I will kindly ask everyone now before closing to turn on their video, so we can take a screenshot and a group photo of everyone who joined us. So if you can please start your video feed, everyone. Okay. No, I'll remove it. Is it good, Maya? Okay, we need more people to turn on their video, please. Not enough. There's 38 of us here, so if we could get the number up a bit more, please. Maya, is it good? Okay, I think the rest cannot turn their cameras on, so we will proceed with the current ones. Yes, please. Okay, we're taking a second one. It's good. We're all good. Someone have on. Allow me only to mute them. Okay. We come to the end. Thank you very much again. Very fruitful, very rich in terms of information. I kindly remind everyone that we're going to be sharing with you the presentations, the questions, the answers, and the outcome of the webinar, as well as the certificates of attendance for those who attended the full webinar. Thank you very much. Have a nice day. See you. Bye-bye.
Thank you.
Thanks for Jill.
Yes, Swang, I can hear you.
Yeah, thanks for Jill. Thanks for reading up.
Thank you. Thank you very much.
Shukran.
Shukran to you as well. I'll be in touch soon. Thank you.
Yeah.